Hello everybody, this is Mrs. Gabriel. This video is going to be on terrestrial biomes. These are biomes that are on the land. So we have an objective of describing the global distribution and principal environmental aspects of terrestrial biomes, and we have 4 essential knowledge points that you'll need to know very well by the end of this. Make sure that you always pay attention to the verbiage in these, as that is what you get tested on by College Board. So there's each of those. All right, you're going to find many charts comparing biomes online. I used to have my students complete one like this as a group, and they would get to draw and talk and learn together. Notice how the latitude and climate and soil and plants and animals are important characteristics that we use to identify a biome. So charts like this are really helpful if you write them out and if you study from them. So we're going to do a little practice real quick. You want to zoom in on it so that you can see it better, or maximize the screen. So what's the soil like in the desert? So to find desert, you have to look up soil, and soil is really important. It's poor. And why is it poor? Because nothing decays once it dies. Why is that? Why is nothing decaying in the desert when it dies? It's not decomposing. Because decay and decomposition require water. There's not enough precipitation to speed the process. If dead things don't decay, they don't give nutrients like carbon and nitrogen to the soil for plants to grow. Hence, we don't have as many plants in the desert. Where else is the soil rich? Look at the chart. Where else do we have rich soil? What biomes? Well, the tropical rainforests, the taiga. Where is soil nutrient rich? Deciduous and grasslands. So the point I'm trying to make is that it's not about memorizing these things. It gets you nowhere, guys. You don't learn by memorizing. You learn and remember by understanding. Preach. Biomes have a specific set of definable characteristics. The amount of rainfall or precipitation, temperature, and plant types are the most important. So abiotic and biotic factors combined, that's what we're looking at. And plant types are determined by soil because there's actually many different soils. And many plants are picky about their soil. Soil type is affected by the temperature and precipitation. So soil is different from place to place because of temperature and precipitation. If the soil is different, the plants that survive in that soil are also different. Now this diagram shows you how these relate. So find a deciduous forest in this diagram. So I love diagrams. Diagrams are great for studying. So deciduous forest, that's the biome you live in here in Maryland, right? Use the diagram to tell me how a deciduous forest is different from a rainforest. You should have said a deciduous forest is cooler. And if I ask questions and you need more think time, just pause. Okay, now how is a chaparral different than a deciduous forest? It's drier, but it is in the same temperature range, close. How is a savanna similar to a rainforest? They're both hot. So I would not just copy and paste a chart like this. I would draw it and make it my own. I would write notes along the side and in extra bubbles. I would draw the trees and maybe list the animals and plants in different colors. By drawing it, I'm committing the information to memory in my brain better. You do have to know this stuff. You will have to memorize it by May. Make your note-taking purposeful and make it meaningful for you. Take notes that help you remember. Creating your own charts and organizers, or taking one you see that you like and then modifying it to make it your own, helps you remember. So this chart is like a graph. The x-axis is precipitation and the y is temperature. But we made the graph look so nice, we're more likely to remember it. But this chart is showing how biomes can also be predictably found at a change in latitude or elevation. Latitude lines are like the equator. Remember the equator line? The equator is 0 degrees latitude. We are all at around 39 degrees north of the equator, by the way. Maryland is 39 degrees north latitude, 39 degrees away from the equator. The North Pole is 90 degrees north of the equator. So increasing latitude, look at the diagram, correlates to specific biomes. Which one do we live in? You should say deciduous. So which ones are typically more north, typically? So again, we have a drawing and we're looking at patterns. So as we move more north in latitude, coniferous, then tundra, then polar. Now look at the elevation correlations. We could find an occasional tundra biome in a very low latitude, like closer to the equator. If the elevation makes it much colder and higher, for example, if we had very tall mountains in Maryland, these mountains would be very cold and very dry at the top. If it's very cold and dry, this would affect the types of plants, so the combined temperature, precipitation, and plants would make it a tundra. So just a reminder, these are the criteria we use to define terrestrial biomes. We look at temperature, precipitation, and distinctive plant growth. And the plant growth is really based on the soil. Okay, a big part of being successful on tests is remembering everything you learned really well. As I said a million times already, you remember by understanding, and even more by explaining. A strategy that has been very successful for me in difficult classes is to practice testing myself using visuals. So we're going to practice how you use a visual to study. So this is one of my visuals. Let's analyze it to understand it. I'm going to give you 2 minutes to test yourself on this map. You're going to pause the video. This is a study tip. Feel free to use your notes. Here's how it goes. I covered the colors and the biomes on this key here, okay, in orange, on paper or on a sticky note, or even in your head for now, or in your own personal notebook. Use the information from your book, your notebook, whatever, and that I just helped you understand to identify the color of each biome. So guess, you have a yellow here. Which biome is this yellow here? And by doing this, you're actually kind of practicing locations of the biomes. You're looking at these latitude lines. It's going to help you with remembering. So pause, and then when you're ready, check your answer, but don't do it for more than 2 minutes. And there's your answer. Now we're going to try it again. This time, I want you to name the biome. You have 1 minute to name the biome. So look at the color, look where it is, see if you can name it. Guess it, jot it on a little piece of paper, and then you're going to pause, and then you're going to check your answers. Another way to study with the use of your notes is to describe the temperature, the precipitation, and the plants, or flora, for each biome while looking at it on a map. So now we have all this information, but guess each characteristic. So find the temperate grassland. Now, by looking where it is, you can imagine where it's going to be wetter and where it's going to be colder or drier. Use that to test yourself on the other information related to that biome. And then you're going to pause, and then you're going to check your notes. And I would only do this one at a time. So if you pick the temperate grassland, I want you to think about, okay, what's the temperature, the precipitation, and the flora? And then test yourself by looking at your notes, like check your notes. If you did well, give yourself a happy face. If you did not do well, give yourself a sad face in your notes. And then just keep practicing. A little help with units before we start on this part. So you might need this because you're not used to working in Celsius. I know everybody's really familiar with Fahrenheit. Just remember this, 20 degrees Celsius is like 68 degrees Fahrenheit. 10 degrees Celsius is kind of cold for me, it's 50 degrees Fahrenheit. And remember that 0 is where ice freezes, or water freezes. 0 is freezing in Celsius. All right, so this is a climatogram. I like having students make these when we're in class and then explain what we can infer about the location based on the information graphed. For example, in the chart on the left, the location gets below freezing for about 5 months of the year. 5 months of the year, 1, 2, 3, 4, 5 that are not shaded. That's what you need to notice. That means that most flora, which is vegetation or plants, right? Most flora would be able to grow only during these months, these 7 months. So the growing season is 7 months. So I know, okay, plants are going to be growing. And then I look at the temperature, I look how much rain there is, and I start envisioning what's it like around me when I'm in this environment. Do I have trees, or do I really only have like plants? Is it dry, or is it wet enough where there's a lot of growth? Okay, so the rain falls all year, but plants are not limited by rainfall. They're not held back by rainfall because the rainfall's always there. So they're always getting the water, but the plants require a certain amount of water, and they require the temperature to be above freezing. So plant growth is limited or held back by temperature for these months of the year where it's below zero. So the amount of water the plant needs is greater than or exceeds the amount that is supplied all the time in here, right? So they always get the water that they need in the first chart. In here, the plant is not getting as much water as it is respiring, because it always respires. It has to get at least as much. If the temperatures are too cold or the water is not enough, then plants still will not grow. And that's a limiting factor. So you're either limited by temperature or limited by precipitation. All right, so let's look at the second chart again. It does rain all year. The temperature's too cold for plant growth for 7 months. The few months the plants have a warm enough environment, it barely rains. It's very dry. So you envision that's very cold, right? And the amount of water the plant needs on the part where they intersect, the part where these lines intersect, the amount of water the plant needs is greater than or exceeds the amount that's supplied. That's a lot to take in. You just might need to pause and practice that. Okay, so I am not going to be reading all this to you. There's going to be several slides where you're going to read them to yourself on your own, and I'm just going to quickly go through it, and then you use it as needed. So as far as forests go, you need to know for a forest to be there, we're talking about trees, right? It does need to always have rain. Forests need to have rain most of the year. Okay, now remember, I'm not going to be talking through these slides. You're going to pause, and you're going to make sure that you understand this. You'll learn NPP next class and the class after. It's primary productivity, and you'll have to get all this together. Tropical season forest, which is also savanna. This is where they're located. This is what the climate graph looks like. And then make sure that you know how humans impact that biome. Subtropical desert. You can pause, you can read it. Make sure that you recognize where these are, what they look like. Think about what lives there because of the temperature, the climate. Temperate rainforest, temperate rainforest. And that's not really clear, but the temperate rainforest is all along the coastline here. It's hard to kind of see. It's all along this coastline, just so you know. Lots of coniferous trees, ferns, and mosses. Lots of trees. Poor soil, acidic soil. Temperate seasonal forest, that's us. That's us. See, we live right there. Oops, we live right there. Woodlands or shrublands or chaparrals. Those names are used interchangeably. And this is what their climate graph would look like. So plants are limited around this time of year by temperature. Temperate grassland or cold desert. So look where a temperate grassland might be. And these maps are so tiny, it's hard, but here's what a temperate grassland looks like. Look at the climate graph. Boreal forest or taiga, which is coniferous, lots of coniferous trees. And plant growth is limited during all these months where the lines, the temperature line is below zero. The tundra is all about permafrost. Permafrost is that almost frozen soil most of the year. So you're not going to get trees in the tundra. Okay, So if you have time, you want to pause here and you want to cover this up. It would be really good practice to create your own climate graph. You're going to cover this graph, and then you're just going to look at this data, and you're going to try and make your own climate graph from it. This has happened on the test before. Kids have often had to interpret the graph. By practicing drawing the graph, you can understand how to interpret the graph better. So when you get a chance, sometime, this week when you have extra time, cover this graph up and then look at the data and try and create your own. And make sure you label your axes and make a legend. Okay, here's another study tip for you. You can use this chart to predict what the climate graph looks like. So look at the tundra here, and then on a post-it note, look at the tundra right over here, and you have precipitation information and you have temperature information. So draw what you think the climate graph would look like for the tundra based on where the tundra is here. And then go ahead and put a little post-it note over this part of the graph. And then try to make another one for boreal rainforest. So you see what the precipitation could be and the temperature could be, and then check these things in your notes. Check your answers with your notes. It's a great study tip for you. So you're looking at the average temperature most of the year to guess how lucrative the productivity of plant growth is too. So think about, can plants grow here when our average temperature most of the time is below zero? Well, we're not going to get a lot of growth. There's not going to be a lot. So think about what that graph looks like and apply it to productivity of plants. So if you have time, I would love for you to get to know biomes a little more deeply. So if time permits, after watching the video, you can find the Bio Interactive Biome Viewer, and you click on the link and there's a worksheet on there. You don't actually have to write in it, just open it in another window or on your phone and explore through this really fun interactive activity. And you can explore here too, and it'll show you a climate graph of any place that you click on anywhere in the world on the graph. Okay, so global distribution and non-mineral terrestrial natural resources include fresh water, oil, coal, forests, iron. These are our top 5 right now. So that was an essential knowledge point that you need to understand. So make sure that you remember, where it rains, we get lots of water. Where we get a lot of water, we get growth. So agriculture really works well if we have a lot of water and it's warm enough. And remember, trees, so we need water. Water is an important natural resource. Trees are also an important natural resource. Forests, lumber is the #1 reason we love this natural resource, right? So lumber is going to be found in a climate where the temperature and precipitation is perfect for tree growth. And remember that if our soil doesn't allow growth, we're going to miss out on everything. So just to review, these are where our forests are, natural resources. And anywhere that is brown is where we don't have forests. Those natural resources are very limited. So as far as global distribution in this essential knowledge point, the global distribution of these things, we do not have this natural resource of forests in any of the brown spots at a nice lucrative level. And as far as fresh water goes, if you look at the top map here, fresh water is an important natural resource for us, right? But the climate and climate graphs really does affect the amount of the amount of water that's available. So you can see how much water is available for us. We're pretty lucky where we live. But if you live over here in the orange and yellow region, because of the climate, you don't get a lot of access to that very important natural resource. And the last essential knowledge point, the worldwide distribution of biomes is dynamic. So because the climate is changing, biomes are also shifting. So computer scientists and environmentalists and climatologists have actually made computer models that show, look where your current biome is for the deciduous forest, the deciduous temperate forest, right here where we live. And if you look in the future based on the computer models, the deciduous forest is going to change. It's going to shift. And that's because of global climate change. If the climate changes, so does the soil, and so do the plants that live in there. So this model predicts our deciduous forest is going to look different. We're going to have more of it in the future. And in the West, we are going to have more or less desert. What do you think? In the West, desert. Look at what we have now. Are we going to have more or less because of global climate change there? Well, we're going to have more grasslands. We're going to have less desert, right? This is because the temperature and the precipitation patterns will change. And that's because climate is changing. Climate's all about temperature and precipitation over a long period of time. All right, that's the end of terrestrial biomes, and I'll see you next time when we go over aquatic biomes.